This video is all about regression line and correlation coefficient. The effective way is to get the scatter plot and also a fit a line. Let us try to fit a line for an example given here. We have got x1 and x2 where x1 represents the year and y1 represents the tornado, and the points are all scattered all over. We would like to get the regression line y1 is equal to mx1 plus b. So this mx1 plus b will be the regression line for the whole scatter plot, and the equation is given as 16.4715 x1 plus b, where b is negative 31710.4. The value for E is the residue, the difference between y and y1. The coefficient R is also there, 0.8399. So it is easy for us to get a value of the point at say 2015 or something like that from the given data. So when you get a regression line, y1 is equal to mx1 plus b, you know what the slope is and what the intercept is. m1 is your slope, and in this case your m1 is positive because it is on the positive side. So though this m1 is very small, your regression coefficient is 0.8399 because the points are all somewhat closer to the line. So in this, we know that E1 is nothing but the residue, the difference between y1 and y. So we can make use of this graph to predict what the values are at a given point, say x1. So you can find the value for y at a given point x1. Now, instead of seeing this given value, let us get the scatter point by freehand method. So we are having a scatter plot by constructing points all over, scattered all over. So I have got from points from A to J. We are going to get a regression line for all these points A to J. We are fitting the line, and the line is y equal to 0.45x plus 3.35. And if I'm trying to get the coefficient, let me list this as L1, and I'm trying to find the correlation coefficient for L1. So the correlation coefficient for the given points where the fitted line is 0.05x plus 3.35 is 0.06. So it has a positive slope and the coefficient is very small. See, when I move these points, automatically the coefficient changes and the slope of the equation also changes. See that y equal to 0.3534, something like that, it changes. Accordingly, the coefficient also changes. So when I move these points around, it looks like I get a stage where the line becomes horizontal to the x-axis. So when it becomes horizontal to the x-axis, we know that the slope of the line is 0. If the slope of the line is 0, automatically the coefficient must be 0. If it has a positive slope, then the slope is positive. And here, see, in this case, the coefficient is 0.99, and some way when the points are closer, the coefficient becomes 1. So it is almost perfectly linear. See, when I change this, when I move these points around, when the line is horizontal to the x-axis, the coefficient becomes 0. See, the coefficient becomes 0. Again, when I move these points around, and if this line has a negative slope, then the coefficient, the correlation coefficient is also negative. See, negative 0.78, like that it reduces. And when I move the points around the line, it looks like this line has all these points closely associated, or in other words, I can say that it has a strong relationship. And in this case, the coefficient becomes